So in this video, we're going to build a basic network object in our Ubiq demo scene. Network objects are components that can help themselves synchronize by exchanging message over the network. You can create a new network object and implement your own network behaviors using Unity and C# scripting. So first, we're going to create an empty object. Well, we call it network object. And under this object, we're going to create a new Unity script and add it to the game object that you want it to be networked. So new script, network script, we just call it. I'll wait for it a little bit. And we can right click on the component to edit the script in the Visual Studio. So in our modal behavior script, we're going to include the Ubiq library, which we can do that by adding the using Ubiq.messaging. Don't forget semicolon. By this, we can access the Ubiq library and all the building functions in Ubiq. So first things first, we're going to create a network context called context. So what is this context? Context will hold the address of your object on the network and allows you to send messages over the internet. Second, we're going to declare a method called processMessage. I think in this case it's public void. processMessage. And for the parameters to fill in, we need to add a reference counted scene graph message. So this will be the message received from the remote end. And after this, we have to call network scene.register. Network scene.register. This in our start method. This is because this registers the component with Ubiq and it gets an address on the network. The return value is a network context which you can store in the member created previously. So in here. And so we just defined our context with the registered network scene. After doing this, the next step will be to define what the message between instance your component will look like. So basically it defines the values will be included in this message. So for this, we're going to create a private struct. Struct in C# is much like the class in Java for object-oriented programming. We call it private struct message. Sorry. So in our case, we like to synchronize the position of the object. So what we need here is public vector3 position. Typically, the Unity objects stores the rotation, scales, and positions in vector3s, and altogether this makes up the transform of an object. The next step will be add code to parse and process incoming messages inside of the message function. Below, we will do that first with a var m equals message dot from JSON message. So this is to parse the message because we don't exactly know what the type of the message will be. So we initialize it with a var. So like whatever the types of message it came in, no matter strings, integers, or vector3, is all fine. It can be stored in the var first. This is one advantage of using C#. So this one parse the message. Then we can, because we already have the private struct message, we can directly change our transform local position to m, which is our message defined before, and dot position. So since we already have a function process message to receive the message from the remote end, we also need a function to send our messages. So to update our message, the best way is of course to implement our statements of sending messages inside of our update function. So we can have if last position. We haven't initialized this yet. We'll initialize this like really quickly. Vector3 last position. So here, if our last position doesn't equal to transform the local position, which means our position has changed during last frame, we can set our last position to our local position. After that, we can use context.sendJSON. So our messages are all encoded in the format of JSON, which helps us to serialize and deserialize it. New message. Sorry, this is not the correct way of doing it. New message. Position equals to transform by local position. So this is the current position. So we're sending our current position towards the remote end to replace their last position. And to do that, we'll also need to modify process message slightly to update last position when a message is received. Otherwise, an incoming message will generate an outgoing message, and two components will send message back and forth in an endless cycle, even if the player hasn't changed the object's position. So we'll have our last position identified here, transform to local position. And after writing all these, we have completed our first network object. And in order to visualize this, well, we can create a child object. We can create a cube underneath our network object. So when it moves, the cube follows it, and we can visualize that very easily. So this is all about this video. Thank you for watching, and hope you have fun with Ubiq.